Okay, let me show you how one of the ChemQuests are designed. This is number 13, Structure of the Atom. And students are presented with information about protons, electrons, neutrons, just some basics, and then some symbols like the hydrogen or the carbon symbols and various pictures that they have to take a look at. Because the first page has no questions, they will often just go ahead and move on to the second page. And pretty quickly, when they read, how many protons are found in each of the following, how many neutrons are found in each of the following, or how many electrons, they do not know what these symbols even mean. So that forces them to go back and interact with the pictures on the front page. And pretty quickly they find out that they can just count up. This one, for example, has 1 proton, 2 neutrons, and 1 electron. So they can figure that out, and they're on their merry little way. Well, later, one of the questions asks them about mass numbers, another one about atomic numbers. Let's look at number 7. What does the atomic number tell you, and can you find it on the periodic table? Now, it's important to realize the students have never heard the term atomic number yet. So when they come across it, they have to look back at the diagrams and they see, okay, atomic number Z. Well, okay, this is the atomic number. What does it stand for? So they go up here and they see several atomic numbers, and they can pretty much deduce that, okay, every single one has these protons. So 6, the atomic number must be the number of protons. And so then they can answer question 7. They can write that it is the number of protons, and then they can check the periodic table, and of course they can find it. The next question, defining the term isotopes. Usually definition questions are kind of pointless. They can just copy it down from the book, but not with how I've designed the ChemQuests. They have only seen the word isotopes right here on the front page. So they have to take a look at, what is this? What are these things? And they have to come up with a definition for what an isotope even is. It may be correct, may be a little off, but they will formulate a definition themselves, and sometimes it's up to the teacher to kind of refine it a little bit during the debriefing process. But I think you will be impressed with how your students can define isotopes. Even if they've never read a definition for it, they can construct a pretty good definition most of the time. Well, let's take a look at the following page. I've got some diagrams here of atoms, ions, and they have to, now they've never been told what an ion even is. So number 10, the first question they see is, what is structurally different between an atom and an ion? And it's the only difference. So they have to kind of figure it out. They have to go and look at, okay, well, let's see, we've got atom and ion. We've got atom, ion. What is the difference? And pretty quickly, now they have to come up with the structural difference. And pretty quickly they see that, hey, you know what? The ion does not have the same number of electrons as the atom. Okay, and so for example, down here with magnesium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 electrons, and the atom had 12. Okay, so they can figure that out. Now, I really like number 11 and 12, how they go together. Okay, number 11 asks them to figure out the mass of an electron. Now, how do they figure that out? Okay, well, they got to compare the pictures. We can see that this mass right here is a little bigger than this mass. How much bigger? Well, it's exactly this 0.05 right here is bigger compared to the 0. So why is it bigger? Well, there is an extra electron if we count them up. So the extra electron is where this mass comes from. So the mass of an electron is simply 0.0005 AMU. Okay. Now, they don't have to memorize that number, and I'm clear to tell them that when we debrief this, but it leads to the next question very nicely. Is most of the mass of an atom located in the nucleus or outside, and how do you know? Well, if all of these electrons have a mass of only 0.0005, then where does all this mass of an atom come from? This is almost 24 AMU, and each electron is only 0.0005. Therefore, most of the mass has to be right here in the nucleus. Most of the 24 AMU comes from the nucleus. So they can deduce that for themselves, much better than just telling them. So this is a quick overview of how the ChemQuests are constructed. It forces students to interact with graphics, pictures, sometimes charts and diagrams, and they can get a lot of information from there, and it is more effective than simply telling it to them.